Hi again, this is Chem 121, Chapter 3. In this lecture, we're going to cover Section 3.4. So in the last two lectures, we looked at the internal structure of the atom, and we learned about the atomic number, mass number, isotopes, and atomic masses. In this section, we're going to take a look at the periodic law and the periodic table. So here's the periodic table that you guys have in your handouts module, although this one's color-coded. You can color-code yours if you want to. There's a really good crash course video. I don't know if you guys have ever looked at any crash course videos. I don't know that they're necessarily that good for the learning, but they're really good for review. So after you finish the section, you might want to go back and listen to it. I think this link is Harry Potter singing the periodic table song. So if you're interested in that, you might want to click on that. Remember, if you want to click directly to these links, always have your PowerPoint in slideshow mode. Otherwise, you can go to the modules and get to the links there. The periodic table is a tabular arrangement of the elements in order of increasing atomic number. So now you know what they're talking about there. The atomic number is the number at the top. So the elements are arranged in order of increasing atomic number. So that elements having similar chemical properties are positioned in vertical columns. So all of the elements in these vertical columns have similar chemical properties. And when the table was originally arranged, they were just put in these columns because they had similar chemical properties. But at the end of this chapter, we're going to look at the reason for that. So there's a theory that explained the reason why all of the elements in the similar vertical columns have the same properties, but we'll get to that in a later section. The periodic law states when elements are arranged in order of increasing atomic number, elements with similar chemical properties occur at periodic or regular recurring intervals. So what the periodic law says is when you arrange elements in this way, when you arrange them in increasing atomic number, periodically elements will occur that have the same properties. So that's what the word periodic in the periodic table means. So this sort of periodic pattern in the table is a pretty commonplace thing. This calendar has a periodic property, and that property is that every 7 days the same day occurs, be it a Sunday or a Monday. So a periodic property occurring in the periodic table is no different than the day of the week reoccurring in a calendar. So when we go across the table and we start over in this first column, and then we go across the table and we start over in this first column again, it's sort of like Sunday showing up once a week or Monday showing up once a week. That's really all the periodic law is saying, that as you go through the table, you'll sort of see elements with the same chemical properties occurring over and over and over, just like you see the same day of the week occurring over and over. So how is the periodic table organized? Well, there's a bunch of different ways that you can organize the table. There's a bunch of different ways you can organize a calendar. So one way is to organize the table into what are called periods or groups. So the vertical columns in the table are called groups, and the horizontal rows are called periods. So these are groups, top to bottom, and left to right are called periods. So these are periods, these are groups. So 7 horizontal rows or periods, and the vertical columns are called groups. Again, elements in groups have similar chemical properties, and we'll see later on why that is so. There's 2 different numbering systems for the groups. There's a 1 through 18 system that's not widely used in teaching. There's a Roman numeral system that's much more widely used in teaching. So I want to go back and show you the Roman numeral system. So notice across the top of this table, you see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 18. So that's one new numbering system. But there's also this Roman numeral system where you have 1A, 2A, and then you jump all the way across and you see 3, 4, 5, 6, 7, 8A. So that's sort of the Roman numeral system where you have these A group, and then down here you have these B's, but the numbers are all kind of crazy and out of order. So the AB system with Roman numerals is the system that we use in beginning chemistry classes because it divides elements up into these A group and B group. And we'll talk more about the A group versus B group and why it's useful. So when I talk about group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, I'm talking about these Roman numerals, not the Arabic numbers at the top. So 1A through 8A, the elements in the middle, the B group, are called the transition metals. So these are all the transition metals. And then these ones down here, they actually fit right in there. So this whole group of elements fits right in this little box right here. So it would go 1, 2, 3, and then all those, and then it would pick up right there. And those are called the inner transition elements. So we have the main group at 1A through 8A, the B group, the transition, and then we have the inner transition metals. So we'll just do a little concept check based on periods and groups. This is sort of like playing Battleship with the periodic table. So you go across and find your group, and then come down from the top to find the period. One thing you want to make sure you don't forget is the period always starts here with number 1. No matter where you are in the table, this is always the first period, even if there's no element here. So this is always going to be period 1, 2, 3, 4. So even if there's no element here, you always count this up here as period 1. So it would be period 1, 2, 3, 4. So go ahead and take a few minutes and do this concept check. Find the different elements based on the group, which goes across the top, and periods, which goes from the top to the bottom. So I stopped the recording for a second because I realized I had the concept check a little out of order. So hopefully you weren't trying to do it because I used some of the names of some of the groups in that concept check before I introduced them. So when I talked about these groups, 1A through 8A, some of the groups have specific names, and I used them in that concept check, and I hadn't introduced them yet. So group 1A has a specific name called the alkaline metals. This is a really funny video if you want to watch this video about the alkaline metals. They are shiny and soft, and they are very, very reactive with water, and this video sort of shows that. Group 2A are called the alkaline earth metals. So alkali is group 1A, alkaline earth metals is group 2A. And then all the way on the other side of the table, the next to the last group, 7A, are called the halogens, and group 8A are called the noble gases. So these 4 groups have specific names: alkaline metals, alkaline earth metals, halogens for 7A, and noble gases for 8A. Oh, for crying out loud. Whenever you find something messed up, you always have to go back 3 or 4 times to get it fixed just right. Okay, so they're in the right order now. Okay, so there's that concept check that we were working on. So this is what I noticed in the concept check, that we had halogen and alkaline earth metal, and I hadn't introduced those yet. So just go ahead and take a minute to work on this concept check. So the group 3A, period 3, is aluminum. Because remember, even though there's not an element in the first period, you count that top part of the table. So even though there's not an element here, it would still be 1, 2, 3 for aluminum. The period 4 halogen would be bromine. Period 4 group 1A would be potassium. And period 5 alkaline earth metal, that's group 2A, would be strontium. So that's one way to organize the periodic table into groups and periods. Another way to organize it is just to divide the table sort of along the zigzag line over by the right-hand side. And everything on the left-hand side is a metal, and everything on the right-hand side is a non-metal. So if you go back and look at your periodic table, you'll see there's sort of this zigzag line that goes down. The only non-metal that's on the left-hand side of the table is hydrogen. So notice this kind of shows that even though hydrogen's on the left-hand side, it actually belongs in the non-metals. So what are the characteristics of metals versus non-metals? Well, most people are pretty familiar with what a net metal is. It's shiny, lustrous. It conducts heat and electricity. It's malleable, which means you can pound it into sheets. Non-metals are basically characterized by the absence of the characteristics that metals have. They're not lustrous, they don't conduct heat or electricity. You can't pound them into sheets. Here are some sort of representative non-metals: sulfur, phosphorus, and bromine. Here we have some aluminum, lead, tin, and zinc. You don't have to memorize the stuff in this table. What's interesting about this table is the characteristics of metals compared to non-metals. Basically, non-metals are all of the things that metals aren't, or metals are all the things that non-metals aren't. They basically have opposite characteristics. Now, interestingly, almost all metals are solids. See if you can think of the one metal that isn't a solid, whereas non-metals can be solids or liquids or gases. Metals conduct heat and electricity, and non-metals don't. And then finally, where did the periodic table come from, right? When the periodic table was initially conceived of, it wasn't in this sort of final form the way we see it now. The elements weren't discovered all at once, they were discovered one at a time. And scientists in the late 1800s arranged the different elements into groups based on the fact that they had similar properties. So this is actually one of the original versions of the periodic table from the original paper by the scientist named Dmitry Mendeleev. This is another really excellent video talking about his discovery of the periodic table. And if you take his table and just rotate it 90 degrees and superimpose it on our modern table, you can see that some of the elements had been discovered, but there are some blanks here for undiscovered elements. And that video talks about how Mendeleev made predictions about elements that hadn't been discovered yet. Okay, so that is section 3.4.